1.7 deals with solving equations and inequalities with absolute values. Okay, remember the absolute value is always going to be positive because what we are doing, we are finding the distance that number is away from 0, and distance is always positive. Okay, now these equations and inequalities will always have two possible solutions or answers. Okay, so we're going to have two possible solutions. So I'm going to ask myself 4 things before I start to solve these absolute value equations or inequalities. First, is there anything out in front of it? Okay, you're looking out in front. So anything out in front of the absolute value out here? No. Is there anything underneath here? No. Is there anything right behind it? No. Then look over here. Is this number positive? Yes. So now let's set up our 2 equations. So I'm going to take the stuff inside the absolute value, x, set it equal to 7. And then I'm going to take the stuff inside the absolute value again and set it equal to the opposite of 7, which is negative 7. There are our 2 possible solutions. We can double check these by plugging them in. Okay, plug those numbers in for x. Now this next one, I'll ask those same questions. Is there anything out in front? No. Is there anything underneath of it? No. Is there anything right behind it? No. I mean, there is equal 3, but that's fine. And then I'm going to look on the other side, and I see the 3 is positive, so I can set my 2 equations. X minus 2 equals 3, and x minus 2 equals the opposite of 3. So then I would solve each one. So I have x equals 5. And then x equals negative 1. Now I can double check these. Okay. Plug them in. 5 minus 2 is 3. The absolute value of 3 is 3. Negative 1. Negative 1 minus 2 is negative 3. The absolute value of that is positive 3. So this next one, there's nothing out in front of the absolute value, there's nothing underneath of it, and there's nothing right behind it except for equals 13. That's fine. On the other side, 13 is positive, so I can set up my 2 equations. The reason why I'm asking those questions is that we have to get rid of all the stuff that's either out in front, underneath, right behind it before we set up our 2 equations. And we'll have an example of that here in a minute. So 2x plus 5 equals 13. 2x plus 5 equals negative 13. So I'm going to subtract 5. And then divide by 2. So x equals 4. Then I'm just solving this other equation. X equals negative 9. There's my 2 possible solutions. We can double check these by plugging them into the calculator. I'm sorry, or plugging them into the original absolute value equation. Now, this next one, I'm going to ask myself the same questions. Is there anything in front? Well, if you look, you have negative 8 out in front. So we have to move that first. So we have to add 8 to both sides first. So now we have 4x plus 12. That's still in absolute values, equals 36. Okay, so now do we have anything out in front? No. Do we have anything underneath? No. Do we have anything right behind? No. And 36 is positive. So now we set up our 2 equations with what we've changed. Okay, so we have to get the absolute value and the contents inside of there all by themselves first before we set up our 2 equations. So now I'm going to subtract 12 for both of them and divide by 4. So the first one I get x equals 6. And the second one I get x equals negative 12. Remember, you set the stuff inside your absolute value, you set it equal to the positive number on the right side and of the equal sign and the opposite of it. Remember, you can pause or stop this video at any time to catch up, okay? Or if you want, work a problem out and then check it as I go through it. This one, we have this 10 in the denominator, so that means we're dividing, so I have to multiply each side by 10. So I have absolute value of a minus 6 equals 40. Now my absolute value is all by itself with the contents inside. The other side is equal to 40, positive 40, so I can set up my two inequalities. I'm sorry, my two equations. So a minus 6 equals 40, and a minus 6 equals negative 40. So you add 6 to both sides to solve both of them. If you notice, we have not been getting just plus or minus a number for our answer. We've been getting two different solutions. Okay? So we may get two different solutions for our answers. Okay, so two different numbers. Not positive 46 and negative 46. That doesn't work all the time. We can plug those in, double check it. 46 minus 6 is 40. Absolute value of 40 is 40 divided by 10 equals 4. Negative 34 minus 6 is negative 40. Well, the absolute value of that is positive 40 divided by 10 equals 4. This next one, I'm multiplying with this number out in front of the absolute value, so I have to divide. So I have absolute value of x over 3 equals 3. Now I can set up my two equations. X over 3 equals positive 3, and x over 3 equals negative 3. So I multiply each side by 3. I have x equals 9. And I have x equals negative 9. So here I got plus or minus 9. So this one actually, we got plus or minus a number. This next slide just shows all the possible solutions for absolute value equations and absolute value inequalities. Here, this blue box shows everything that we've just done. Okay, we set our absolute value equations equal to that number and the opposite of it. Now, when we get into inequalities, okay, there's a couple ways to remember these. This in the red box, these are less than signs. So less than and less than are equal to. These are and inequalities. Okay, and the way I remember that is less than. Okay, so instead of thinking less than, we have less than. So think, absolute value of x is less than p. Okay, so we would set up two inequalities, which is what we'll do here in a minute. The next one, the green box, deals with or inequalities. Well, these are greater and greater than or equal to. The way I remember this is instead of spelling greater, G-R-E-A-T-E-R, I spell it O-R, and I pronounce it differently. I say greater. So it reminds me that if it's greater, then it's going to be an or inequality. Okay, so let's try this first one. 4x plus 2 That's all in absolute values, greater than 6. So I'm going to still start it the same way. Is there anything in front? No. Anything underneath? Anything behind it? No. And the number on the other side is positive. So I'm going to set up my two inequalities. And actually, before I do that, think about this is a greater than or equal to, so it's an or statement. Okay, so now my two inequalities. 4x plus 2 greater than or equal to 6, or 4x plus 2. Now, here's where it gets a little tricky. For the second inequality, we are going to flip it. So less than or equal to negative 6. So just like the equations, we set them equal, or we used our inequalities, equal to 6 and the opposite of 6, but for that second inequality, we have to change the inequality symbol. So now I'm going to subtract 2 from both sides and divide by 4. So x is greater or equal to than 1. And the other side, I'm subtracting 2. So 4x is less than or equal to negative 8. Divide by 4. I get x is less than or equal to negative 2. Now make sure you put your statement in there. Okay, this was an or inequality. So now if I want to double check it, remember we talked about or inequalities when we graph them, go away from each other. So I'm just going to make a short little graph here. Here's my starting point of 0. So x is greater than or equal to 1. So it's a closed-in circle. Greater, going to the right. Then x is less than or equal to negative 2. Closed-in circle. Less than, going to the left. So this or inequality should be graphed, going away from each other. In this case, it does. Okay, this next one, there's nothing out in front of the absolute value, nothing underneath of it, and nothing behind it. And on the other side, you have a positive number. So we can go ahead and start to set up our two inequalities. This is a less than, so it's an and inequality. So I have 3x minus 2 less than 4, and 3x minus 2. I'm going to switch the inequality like what I did in that last example, then make that negative 4. So now I'm going to add 2 to both sides. So I have 3x is less than 6 for the first one. Divide by 3. I get x is less than 2. Then I will solve the next one. I get x is greater than negative 2/3. Remember, if we divide by a negative, then we have to switch the inequality symbol, or if we multiply it by a negative. So now, just to check this, I'm going to graph it. Remember, and inequalities go towards each other. So when we graph them, so here's my starting point of 0. 2 is over here. X is less than 2, so it's an open circle going to the left. X is greater than negative 2/3. Well, here, let's say negative 1 is over here, so negative 2/3 would be somewhere right around here. And we want greater, so it's going to the right. So our solutions work there. Okay, so try a few problems of these. We will go over more tomorrow. Have a good night.